Okay, yesterday we took a more general look at solving equations. So today we're going to look at some special cases and talk about some inequalities. So our two special cases are the identity and the contradiction. So your identity is an equation that is true for all values of the variable. Okay, that means that no matter what number I plug in for v, for instance, in this equation, that I'm going to get a true answer all the time, every single number I pick. Okay, the opposite of that is your contradiction. And this is an equation that has no solution. So again, no matter what number I plug in for v, that would mean if it was a contradiction that none of them would work out. I would always get something that was untrue. Okay, let's see how that works when we're actually solving equations. Okay, so you're just going to go through the same process you always do. So draw your line down your equal sign. Okay, on the left side we notice we have like terms, so I'm going to combine those. Negative v minus 9 equals, and over here I have parentheses with a negative outside, so that leads me to leave to distribute. Negative 5 minus v. Okay, and then like yesterday I have variables on opposite sides, so I'm going to move them to the same side. So I'm going to add v and add v. Okay, and here they're going to cancel, and here they're going to cancel. That leaves me with negative 9 equals negative 5. Alright, depending on what you get as your result will tell you if you have an identity or contradiction. Okay, we got a false statement. That is not true. So that means that every number I plug in for v will always give me something false. This is when you have no solution, so you put v equals, and the symbol for no solution is 0 with a slash through it. Okay, that's also called the empty set. We talked about that first day of school. Alright, then we can write this is a contradiction. Alright, let's take a look at this one over here. Alright, same deal. We're going to distribute over here. So that is 6 minus 9x equals. Okay, this whole negative 2 right here is going to get distributed into the parentheses. So that's negative 7x minus 2x plus 6. Okay, and then we're going to combine our like terms with these, negative 7 and negative 2. That's 6 minus 9x equals negative 9x plus 6. Okay, get your variables on the same side, so add 9x to both sides. Cancels, cancels, 6 equals 6. So this is the other type. Whenever you get something like this that is always true, okay, then you know you have your identity. So x equals, and we say all real numbers, so you can write the real number symbol we learned, and we can write identity. Alright, next thing we're going to do are inequalities. So we have an inequality, and this is a statement that compares two expressions using the following symbols. Okay, you should be familiar with at least the first four. You got your less than, greater than, less than or equal to, greater than or equal to, and then the last one you have your not equal to, which we don't use all that often, but you will see it every now and then. Solution set of an inequality can be expressed on a number line as an inequality statement or an interval notation. We're going to do all three. Okay, and remember, when multiplying or dividing by a negative number, you must flip the inequality symbol over. Okay, that's the number one mistake made with solving inequalities, so we'll make sure we remember that. Alright, process is the same. So I have variables on both sides. Doesn't matter which one, I always try to move the smallest number. That helps me avoid this whole reminder thing. I don't have to worry about negatives if I move the smallest one over. Negative 2, greater than or equal to 5a plus 8. Okay, then we move our constants over to the other side, so I'm going to subtract 8, negative 10, greater than or equal to 5a, and then I'm going to divide by 5. Negative 2, greater than or equal to a. Perfectly acceptable way to write your answer. Keep in mind that you could write a on the left side. A is less than or equal to negative 2. These are the same thing. Okay, that's your inequality form. Okay, if you go up here, it can be expressed on a number line as an inequality statement. There we go. Okay, next, in fact, we are going to express it on a number line. So on my number lines, I'd like you to put 0 on there, and then put the point that we are looking at. So in this case, negative 2. Okay, make sure it's on the correct side of 0 and appropriate spacing, things like that. Alright, then we fill in what circle we need. So this is an equal to. That tells me it should be a closed circle. And then it's less than. A is less than negative 2. And less than goes to the left. So shade that way with an arrow. We also want to write our answer in interval notation. So remember, you always start from the left, the smallest value, and work your way to the right. So on the left I see an arrow. So I know that that arrow to the left goes to negative infinity. And I always put parentheses on my infinities. Comma, and then I work my way up to negative 2. And since it's a closed circle, I know that's included in the set, and that tells me that I need to use a square bracket. Alright, let's take a look at this one over here. Okay, we have some like terms here. We have x plus 6x, that looks like 7x. Then we have 1 plus 1, that is 2. Greater than, over here we want to distribute the 3x minus 12, and distribute the negative x plus 4. Okay, then we need to do some combining over here. 3x minus x, that's 2x, and negative 12 plus 4, that's negative 8. So now the greater than, the 7x, and the plus 2 over here. Next, I'm going to subtract 2x from both sides. And we get 5x plus 2 greater than. And over here, those cancel, and we get negative 8. Then we're going to subtract 2 from both sides. 5x is greater than negative 10. Okay, starting to look a lot like our last problem. Divide by 5, divide by 5, and we get x is greater than negative 2. So there's our inequality form. Remember, we have 3 forms to do, so we're going to graph it next. Okay, so it's going to look very similar. We're going to have our 0 and our negative 2. Okay, differences this time though. No equal to sign on my inequality, so open circle, and it's greater than instead of less than, so I'm going to shade it to the right. Then we're going to write our interval notation starting on the left. Okay, that's going to be a parentheses because this is an open circle, negative 2, and it goes up to positive infinity with the arrow. Some word problem vocabulary. So if you see the words at least in a word problem, this means greater than or equal to. Okay, that means we want at least this much money, but we would like to have more. So at least, that's equal to or more. Okay, if you see the words no more than, that is your code word for less than or equal to. Okay, no more than. Bob, you can spend $100, but no more than that. So $100, but we would really like you to spend less than $100. Alright, and then the less than and greater than will just be more normal. It'll just say be less than or greater than. Okay, they'll use those actual terms. They might say more than instead of greater, or fewer than instead of less, but it'll sound basically the same. Alright, but these two are kind of some code words there for your equal to symbols. Alright, enjoy.